So there are just a few basic concepts here in this topic of costs that we need to look at. So I'll just draw your attention here to the chart of figures first of all. And this is as complicated as it's going to get, where you're given the costings of a particular firm for a particular unit of output. So it doesn't matter what they're making, let's say tables or whatever it is. So the first thing then just to note is the fixed costs, which never change. In the short run, at least one of the four factors of production will remain unchanged. So that means that the mortgage, let's say, of the premises is 25, this could be 25,000 euros. No matter what the output is, it doesn't change. So if you produce nothing at all, you can see there that there's no variable cost, but there is still a total cost because the fixed cost must be paid, the mortgage must be paid each month. And if you produce 8 units, the fixed cost is still the same, but the variable cost of course increases, so your total cost then naturally will be higher. So to look at then just the issue of variable costs, you can see that if you produce nothing, then you pay for no timber or you pay for no labour. So you don't have any variable costs, and they're costs that increase in line with production. That's why they're called variable. So if you produce a small amount of output like 2 units, fixed cost, remember, stays the same, but variable costs then are 27, could be euros or 1,000 euros, whatever. So if I produce 8 then, fixed costs again remain the same, but my variable costs then are 145 euros because I'm making a lot of tables. So this column then just shows the total cost. So in other words, it's fixed cost plus variable cost equals total cost. And right the way down the line then, you just add fixed cost in each case to variable cost to get total cost. Now the curves are derived from the average of these things, the average fixed cost, the average variable cost, the average total cost. So that is simply derived from taking the fixed cost for a particular amount of output and dividing it by that amount of output. So the average fixed cost if I produce 1 table is 25 euros. If I produce 3 tables, then it's 8.33 euros, and it keeps falling in line with output. So the more I produce, then the less my average fixed cost will be, because it's being spread over a greater number of units. And just to look at then how that translates then, or helps translate, if we look at the average cost curve here, the blue one, you can see that as output increases, average cost starts to decline. Now there's a third diagram here that just is the graphical illustration of all of these, and it shows us there, you can see average fixed cost is in blue, so it continues to decline. So it will then help pull average overall costs, average total costs down, because average fixed cost then is being spread over a greater number of units. The next issue then we have is average variable costs, and that is then found by dividing the variable cost by that amount of output. So 20 units divided by 1 is 20, and 145 then divided by 8 then is 18 euros and 13. So you can notice then what happens to average variable cost is that it initially starts to decline, but then starts to increase again. Okay, so to find out then, how is that going to affect average cost overall, you simply add average fixed cost to average variable cost, and that will give you overall average cost. So you'll notice what's happening here, that average cost falls, continues to fall, then starts to rise again. Okay, so that then is illustrated here in this blue curve, where the average cost curve declines and declines and declines with output, but then starts to increase again. So you're often asked in the exam, to explain the reason for the shape of the average cost curve. So it declines, it's U-shaped, but it declines because average fixed costs decline. In other words, fixed costs are now spread over a greater number of units, therefore reducing the average fixed cost, therefore reducing average cost. Okay, but there will come a point then where average cost will start to increase again, and that is because of diminishing returns, the law of diminishing returns, that as in any unit of production or any factory or even a school, where you add more and more units to the same size classroom, the same size factory, diminishing returns will inevitably kick in. So if we have 25 people in our class, our average costs may be at a minimum. But if I start adding more individuals to the class, you can see how we become, less efficient. Maybe we only have 25 tools and we have one tool for every individual, but we get 5 more individuals, we still have only 25 tools. Diminishing returns kicks in. So the average cost curve will start to increase. Now, key to understanding the shape of the average cost curve is also the shape of the marginal cost curve. Okay? And the marginal cost curve is simply derived by taking any number of units of output that you like. Let's just say 4 units of output. Okay? So the fixed cost is there, the variable cost is there, and it gives us a total cost of that. Okay? And then ask the question, what was total cost before you produced that marginal, that extra unit? So if total cost is now 70, I just look up here and I can see that it was 60, and that tells me that marginal cost is 10. And you can see that with any one of them, if you want to find out what marginal cost is, let's say that it's TC8 minus TC7. So that would be TC8 minus TC7. In other words, TC, total costs from producing 8 units, minus total costs from producing 7 units. You can see it's 40 there. So that's the marginal cost of 40. And that is graphically illustrated here in the orange. So we can see that initially marginal cost starts to fall, and that again is explained by the better distribution of fixed costs across the units of output. But that marginal cost, then we can see it here in the graph, right, quickly then starts to increase. So the law of diminishing marginal returns is kicking in. In other words, we're getting that bit less efficiency. It's costing us that bit more as we increase our output. So essentially the marginal cost curve is U-shaped. And then that is reflected in an average cost curve, which is also U-shaped. Now these are the 2 most commonly asked for curves, but I've just illustrated here, just in case that the question could be asked, I've just graphically illustrated average fixed cost, average variable cost, and then average cost, which is the blue one up above. That's average cost there. And then, of course, marginal cost. So it's a less commonly asked question, but it can still appear on an exam to graphically illustrate all 4 curves. But again, if that were asked, you would have to be given this data here in the chart. And the final concept then is that of the long run average cost curve. We call it the LRAC curve. And it is simply derived from joining the most efficient point, which is always the lowest point, on the average cost curve, the most efficient point, okay, to the most efficient point on a second short-run average cost curve. So you only ever go into a second short-run average cost curve. So just to illustrate that there, the graph initially is the AC, and we would call it SR, short-run average cost curve 1. So if I go into a new short-run, that means then that all 4 factors of production now change in quantity. So the one that was fixed was more than likely the size of my premises. Now I've built an extension onto the premises. So I am now in a new short run. So there will be a new set of figures back over here in this chart, because there will now be a new fixed cost. The mortgage was €25 a month. It's now €75 a month, or whatever it might be. So I have to do a second short run average cost curve. But that's derived in exactly the same way. So you would just simply go back over here and these figures would change. And inevitably variable cost would also change as well. So that would give me a second short run average cost curve. So I'd just call that SRAC2 and so forth. You would have a third one then if you built another extension, and a fourth one and something like that. So the most efficient point there, it's always the lowest point on the average cost curve. So I would simply, this is not coming out too well, but I would join those most efficient points and get a long run, and just you need to check my notes for this diagram on the long run average cost curve. So the long run average cost curve is simply derived by joining the most efficient point on all of the short run average cost curves. So it will be U-shaped as well. And the only difference here is that the reasons for the downward sloping portion of it are economies of scale, and the reason for the upward sloping part of it are diseconomies of scale. In other words, efficiencies related to size will cause long-run average cost curve to decrease, and long-run average costs will increase because of diseconomies of scale. And those terms are both explained in my notes. So I hope that clears up that that's more or less everything you need to know. If you can understand the terminology used here in the graphs, you should be okay for costs. There's no other concept related to this topic. It's simply practice, understanding this and then being able to translate it into a graph, then being able to explain the reasons for the U-shaped short-run average cost curve or the flatter but still U-shaped long-run average cost curve.